Hello, welcome. This is the prototype flexible industrial robot. This was custom made. We have the control strategy to test, and we have the prototype robot, which is placed on the electrical rail, which is controlled by this box. Normally we have the DC, this is the AC servo motor to drive the system. And also some stepping system at the end. So this servo motor was from San Motion, which is from Japan, from Sanyo Denki. So this is the built-in sensor, and also we have a drive to drive each motor. If you look at this one, we have the motor drive to drive this system. This is the mechanical system for the first joint. We have the two linear guide to support this system. For that, we also have the ball screw and also have this screw to support the weight of the body of the industrial robot. So it means that we can move the industrial robot along the way. So it's around 1 to 2 meters to give more flexible of the operation, to expand operation of each robot. And this link was controlled by the AC servo motor as well, and it's linked to the controller here, and that we can have more flexible system. This was designed to have become flexible. So we have the flexible system installed here. If you look at this one, we have a flexible system. When I push this plate, it will move along the way. So the base is not moving, but the top of the robot is moving. So it can support the dangerous of the robot movement. When it hits something, it has a flexible system to remove the dangerous, but however, it's caused the vibration, it's caused the inaccuracy when it's moved. So it can be eliminated by the control strategy that we develop. We also have the sensor attached right here, and also sense the location of the movement of each difference between the flexible system and also with the stationary system. So we was designed with a rail which the robot can move along this rail. That is the first link, is the linear movement. Also the second link is also the AC control motor, and that drive the movement of the rotational. So this is a plate that we designed by ourselves. So this plate was moved by the motor here. So this was directly driven by the motor, and also we have the gear attached here. But however, we have the flexible system right here. If you look at this one, you will see the system can be flexible by this spring. So it means that we have the fixed stationary and we have a flexible system here. So we have the wheel, the support for this flexible. We have the spring for both sides for a flexible system, and also we can define what is the flexible position for this one. So we attach the encoder to send what is the position by this encoder. So it means when we control the robot, sometimes it move slower, but it's more safe and more reliable for operation with a human. For the last two joy, we have no flexible from the spring directly. There are also some small flexible, which is called from harmonic gear here. Is one ratio of harmonic gear is a little bit flexibility. You could not observe directly. For the last joy, we also have the motor right here is also industrial motor from Sand Motion, but from different model, which is a stepping motor. Right here we have the flexibility here with some belt and pulley, which cause some flexibility, and also we have move dislocation, and also we have the screw drive. Screw drive here is a screw with a supporter, and that to change the rotational into the linear movement at the end, and that's supported by the linear guide for this system. So this become the 1, 2, 3, 4, 5 axis. We have 5 motor at the base as the linear movement on the linear screw, and second one, and third one, and the fourth one. So we have 4 axes of the motor, but however we can add more tool at the end, like we can use the pneumatic system or electronic gripper. So that's it, a flexible motor for development, and we apply the control strategy to eliminate the vibration of this robot. It's worked well, and see you again later.